Namaste. Good morning, guys. All right. This is a 2-minute video that's going to go. That is an explanation of the tone generator activity that you guys did. A lot of you guys got. Some of you guys got it right. A lot of you guys got it really close, and so I just wanted to explain this. I just wanted to explain it for you so you understand like what's going on. All right, and all right. So check it out. So when you play the 400, it's all about interference, constructive and destructive. So I was looking for that in your answer. All right, but and when you play the 440 hertz tone, what that is just a nice, you get a nice wave, okay, like that. Now the reality is this is inaccurate because sound is actually a compression wave, and I drew a transverse wave, but it's just easier to show you what's going on if I do a transverse wave. So just bear with it. All right, so let's say this is your 440 hertz, right? And then you play the, like, for example, the 441 or the 442 at the same time. What the two waves are going to do is they're going to overlap and meld with each other. Or in other words, they're going to interfere with each other. Because remember, unlike particles that when they come in contact with each other, they collide, and you either get an elastic or an inelastic collision. All right, with waves, they meld through each other. So when you play the 441, for example, all right, that's a higher frequency, and so the troughs and crests come faster. All right, and they do something like this. Okay. So they overlap like this, and you can see in different areas right here. So here's the crest of one, and it's meeting the trough of another. Well, what's going to happen? They're going to destruct, okay? And for sound, the amplitude, so that means they're going to flatline for an instant, all right, and or create a very low amplitude. And for sound, the amplitude is reflected in how loud it is, okay? So loud is a high amplitude, soft is a low amplitude, okay? So now notice these two waves could have the same frequency. It's just that this one has a higher amplitude. We know this one has more energy to it, okay? So you see a crest here and a trough here. They're going to flatline there, and what does that mean? You're going to get low sound. You're going to get, if not nothing at all, you're going to get a very low sound. Over here we have a crest meeting with another crest. So what's that going to do? They're going to construct. They're going to make a bigger crest right there. And what does that mean? That means it's going to be louder. And that's why you hear that pulsing sound. You hear that, that kind of pulsing of loud, soft, loud, soft, loud, soft. All right. And when you hear that, that phenomena is called a beat. Okay. The pulsing phenomena is called a beat. Okay. And the amount of beats you hear is the difference between the frequency. So beats is the amount of beats you get when two waves overlap is actually the difference between the frequencies. So it's the frequency difference. And what do I mean by that? Well, when you play the 440 and the 441, there's a difference of 1 hertz between the two frequencies. So you tend to get 1 beat every second, or 1 like pulse per second. Okay, per second. And when you played the 442 over the 441, most of you guys described this correctly. You heard the same phenomena, except it was faster. And notice the difference between the two frequencies is 2 hertz, and so you get 2 beats per second when you overlap those two. And if you were to do something like the 450 over the 440 and play around with it a bit, you notice this pulse is like really, really fast. It does that, because there's a 10 hertz difference between the two frequencies, and so you get 10 beats per second, okay, if you overlap these two sound waves, all right, so, or these two frequencies. So, all right, so I just wanted to explain that. If you have any questions, come and see me during my office hours at 10 o'clock. All right, good luck, and Godspeed, and enjoy your apocalypse.